So let's start this one. 2003 question 4, non-calculator. Let f be the function defined on an interval when f of 3 equals 0. That's an initial condition. They give you the graph of f prime. I know my board's not real good, so I'm going to make that nice and big. Consists of one line segment and a semicircle. Oh boy. They tell you that so you can find the area under those curves. So you can make shapes, guys. That's why they tell you that. On what intervals, if any, is f increasing? Guys, this is a derivative. F is increasing when f prime is positive. So increasing when f prime greater than 0. So the only place it's increasing, guys, is -3 to -2. It says justify your answer. Increasing when f prime is there, so I think I got this. Yep. Increasing when f prime is greater than 0, that's the reason. On the interval -3 to -2. 2 points. One for the reason, one for the interval. I think that's an easy one. 2 points. Boom. All right. B. Doing red. I like colors. Find the x-coordinate of each point of inflection of the graph of f on the open interval. Justify your answer. Okay. Points of inflection, pi, occur when f prime prime changes sign. You guys agree? So we got to see, I see that f prime prime is negative from here to here. You guys agree? And then f prime prime is positive. Because, guys, I'm looking at the shape of the curve now. The slope. Yeah, because I'm looking for the derivative of f prime. So I see a point of inflection at 0. So there's one at x equals 0. And, again, there's a sign change at x equals 2. Pi occur when f prime prime changes sign. And I would probably make a note that at 0, at x equals 0, f prime goes from decreasing f prime prime. It goes from decreasing to increasing. You guys agree? The function was getting smaller, then it starts getting bigger. So it goes from decreasing to increasing. And at 2, f prime goes increasing to decreasing. All right, that would be my notes. All right, 1 point, but you have to have 0 and 2. And then 1 point for justification, okay? You have to have a reason about increasing and decreasing. You probably don't need the first note I had. All right? And again, think about it, guys. This is like why we memorize these rules, the concavity rules, the second derivative rules. And again, Calc 2, got all kinds of problems. Calc 2 will rely on a lot of that too, so you guys are going on, you want to know those. All right. Letter C. Find an equation for the line tangent to the graph at point 0.03, your initial condition. So I have point 0.03. What is f prime of 0? F prime of 0, if I look at my graph, is -2. And it wants an equation. So I would write point slope form. And then I would solve it by doing this. Does it say justify? Nope. I'm done. The equation. 1 point for y equals -2x plus 3. All right? That's letter C. Now, I would say the first 3 of these, think about it, we've done 2, 4, 5. So the last one's worth 4 points. This is it says find f -3 and f4, show the work. Again, if you're going to find the function, you've got to start from what you know, which is the initial condition. And then you have to use the derivative. And I will use the variable t. All right? And again, remember, when you integrate it, the area under the curve. So I'm going to then put in 3 plus, not plus. Yes. Yes. Because it's on, because I'm making a video. So yeah, even though we just did this, I'm doing it again. And everybody, this is the area under the curve. I can't stress that enough. That's what integrals are. So all you have to do is find the area of this triangle that's positive, the area of this triangle, which is negative. 1 by 1, 2 by 2. Here we go. 3 minus. The area of the first triangle is 1 times 1 divided by 2. That's positive. The second triangle is negative because it's below the x-axis. We've got to do a little bit of math here. And I get f of negative 3 equals 4.5 when you do the math. All right. When I look at this one, they are going to give a point for the fundamental theorem of calculus right there. They're going to give a point that you have the correct differences in triangles right there. They do not give credit for 4.5. Really. So 2 points. 4.5 is extra. So I'm going to guess on the next one they don't give credit for the answer either. Oh, they do. They give credit. Oh, wait a minute. They do want an answer. You got to have this and this. Okay, so let's be. I'm sorry, I looked a little close. Let's be clear though. If you just write 4.5, you're not getting a point unless you show that the fundamental theorem of calculus is used to get there. All right, let's do. I'm going to make this small because otherwise we can't see the graph. We're going to have. The next one's a lot more complicated than the other one. Yeah, because it has a circle in it. It's not, it's just a different shape. All right. So f of 4.
Remember the homework on like cylinder shell one?
Yep.
Did you ever wrote that in class? Yeah.
Like 6, 7 times. If you want, I can make some more examples. I also taped some if you watch that.
Wasn't this like, it's just the same thing as a different area, right?
All right, so again, initial condition is 3 this time. And this time, guys, the area under the curve is a pain in the butt. I see a rectangle minus the semicircle, right, guys? Or you can do 2 times the corner, yep, if you want. I'm going to do the rectangle minus the semicircle. The rectangle, and again, you guys agree the whole thing is negative because it's underneath the curve. So I'll put the negative on the outside. The rectangle is 2 by 4. The semicircle is pi r squared over 2, and the radius is 2. So I get 3 minus 8 minus 2 pi. So I get 2 pi minus 5 is the answer for f of 4. And that is the answer. And again, 1 point for this junk. 1 point for the answer to the fundamental theorem of calculus.